Hey everybody, this is 7-3, day 2. We need to do one last thing about the sum and difference identities. We're going to take a look at what if you don't know anything about the angle. So there's no angle measurement at all. What they're giving you is information about ratio. So we're going to take a look and see how that's different than the ones that we were doing before. So first of all, let's kind of piece through the information they gave us. They want us to find the value of the difference of those two angles. So they want us to do cosine of x minus y. So the very first thing I would do is go ahead and write out that cosine difference formula. So cosine of the first times cosine of the second. It's a difference, so sum, sine of the first, and then sine of the second. So we know what we're trying to deal with. I need all four of those pieces, sine and cosine, for both angle measurements to be able to figure out what the cosine of the difference is. Okay, let's see what else they gave us. Nowhere in here do they tell us exactly what angle x and angle y are, but they did tell us these two pieces of information about x and y. They say x and y, both of them, are between 0 and pi over 2. So between 0 and 90 degrees. Well, where does that put you? Well, you're in quadrant 1, right? So for each of those, these are quadrant 1 angles. Why do we care about that? Well, if we go into other quadrants, those angles might give us things that have negative ratios. So like if we're in quadrant 2, for example, cosine would be negative, tangent would be negative. So it's really important that we realize that that's what we're being given. All right, what else did they tell us? They told us something about angle x. Cosine of x is given to us as the ratio 2/3. So realize right away here, they're not telling us the angle. We don't know what x is, but we know what cosine of x is. We know that ratio. The other thing that they told you, I'll do this one in blue, is that y triangle, this other triangle, the cosine value is 4/7. So we know a little something about each triangle. Now, if you know a ratio, what do you actually know about this situation? If you're given a trig ratio, you know. If you're saying two sides of a right triangle, give yourself a pat on the back. That's exactly right. You know two sides of a right triangle. So you're going to be able to go through and draw those pictures and find anything you need. So we need to draw two triangles. So I'll keep color coordinating here. So my triangle number 1, my x angle, cosine is adjacent over hypotenuse, and I can solve and find that third side. So 3 squared would be 9, 2 squared would be 4. So our third side is square root of 5. And then my other triangle, also in quadrant 1, my y triangle, not to scale here, but just to get some values, cosine as well, 4 and 7, so adjacent hypotenuse. So we need our other side, so that would be what? Square root of 33, 49 minus 16. Double check that arithmetic, make sure we're okay here. All right, so now we have everything that we need to know about both of those triangles, so we can do some replacing. All right, so I'm going to keep color coding here. So we need to know what the cosine of x is. Well, we actually could have gotten that right from the beginning, right? We knew what that value was, but you can also now look back and see it's 2/3 in the triangle. So cosine of x, that relationship, is the fraction 2/3. Notice we don't know angle x, but we know what cosine of angle x is. All right, now I'm going to keep my color coding here. Cosine of y, I need to look at the y triangle, so the blue one. Cosine would be 4/7. Again, they gave us that value, but we can also look at the triangle. All right, then plus, keep my color coding going here, sine of x, so I look at my x triangle, sine of x would be opposite over hypotenuse, so square root of 5/3, and then sine of y. So in the y triangle, so down here, sine would be opposite over hypotenuse, square root of 33/5. All right, so now order of operations, I need to multiply and then add. So multiply would be 8/21. Now when you multiply radicals, remember you multiply the numbers underneath, so there's no shame in scratch work. All right, so we'll go ahead and multiply. So we'd have square root of 165/15. All right, so that means cosine of the difference of two angles would be 8 plus the square root of 165/15, which is a positive answer. So let's think about if this makes sense. If you take two quadrant 1 angles, because remember both x and y were in quadrant 1, and you subtract them, does it make sense that our cosine answer is still positive? All right, so let's think about where you'd end up. If you take two quadrant 1 angles and subtract them, what quadrant could you be in? Well, If x is bigger than y, so say 40 minus 30, then you'd be 10 degrees, you'd be in quadrant 1, so yeah, cosine would be positive. What if y is bigger though? If you do 30 minus 40, that would be negative 10. That would put you in quadrant 4. But isn't cosine still positive in quadrant 4, right? It's the x value. So think about what's reasonable. We're trying to express something we didn't know using things that we do know about this angle theta. Now, you could, if you wanted to, you could go back using what's in the red box and the blue box. You can actually figure out the angles for x and y. We've done this already when we did SOHCAHTOA. How would you solve for x and get rid of, or a better way to say undo, cosine? Well, you do the inverse. So if you type into your calculator the inverse cosine of 2/3, make sure you're in degrees, and you type in the inverse cosine of 4/7, you will actually get the angle measurements for these. And I'm trying to remember what they were when I calculated them before, but I know the y is bigger. So one's like 40 something, one's 50 or something like that. So this would definitely be a quadrant 4 angle then when we looked at those values. So always think about what's reasonable. That's really important. Okay, let's try a couple more here so we can try the other two formulas. So we're going to do a sine formula of alpha plus beta. So again, the first thing I would do is whatever they're asking me to find, go ahead and write out that formula right from your formula sheet. Sine of the first, cosine of the second. When it's a sum, it's a sum. Then cosine of the first, sine of the second. So now I know what I'm dealing with. I need sine and cosine from both of those angle measurements. And what do we know about the angles? They're in quadrant 1. Fabulous. And I know some information about each of them. I know something about alpha, and I know something about beta. So that's what I'm going to use then to draw my pictures. And remember, if you go into another quadrant, you're going to have to keep track of signs, positives and negatives. We're just trying to start with kind of nice quadrant 1 for now. So let's do the alpha triangle here. They said cosine was 5/13, so adjacent and hypotenuse. That means my third side would be 12. So do the Pythagorean theorem. 169 minus 25, that's 144. Square root of 144 is 12. Some of you might remember the 5, 12, 13 triangle. Okay, and then what about beta? My beta triangle, I have sine of beta, so that's opposite over hypotenuse, so 4/5. And then the adjacent side would be 3. So a 3, 4, 5. 25 minus 16 is 9. Take the square root. Okay, so let's go ahead and substitute in what we need. I'll try to keep my color coding going. So I need sine of alpha. They didn't give that to me in the given information, so I have to look at the triangle. Sine of alpha would be opposite over hypotenuse, so 12/13. Now jump over to your beta triangle. So I need cosine of beta. So my beta triangle cosine would be 3/5. And then now back to the alpha triangle. So cosine of alpha would be 5/13. That's actually one that they gave us. And then sine of beta. So back to the beta triangle here. Sine of beta would be 4/5. So I'm going to multiply and then add. So that would give me 36/65 and then 20/65. So that means sine of alpha plus beta is going to be 56/65. So let's think about reasonable again. Remember when you do the graphs for sine and cosine, the biggest output on your graph for sine or cosine is always 1, right? And then -1, so those are your max and min values. So you should never get an answer for one of these bigger than 1 or less than -1, because you did something wrong in your arithmetic then. They should be within that range. Other thing is, okay, we're taking two quadrant 1 angles and we're adding them. Where could you end up? Well, if you take two quadrant 1 angles and add them, they could still be in quadrant 1, right? If you had like a 30 and a 40, that'd be 70, still in quadrant 1. So does it make sense that sine is positive? Well, sure, everything's positive in quadrant 1. But what if you take like a 70 plus a 60? Those are both quadrant 1 angles. That would put you in quadrant 2, 130, right? Well, does it still make sense though that sine is positive? Yeah, because sine's the y. It should be positive in quadrant 1 and 2. So again, if you actually wanted to figure out these angles, you could do inverse cosine of 5/13. Just make sure you're in degrees so you can recognize it, or inverse sine, right, of 4/5, and you can actually figure out the angle measurements if you need to, or if you're thinking that you want to just to kind of double check where those are. So we're taking things that we know about the original triangles and being able to find new angles with that. Okay, so we're going to finish up this day 2 just with doing a tangent example so we can see what that looks like. So again, start with the tangent formula so you know what you're simplifying or what you need to simplify. So it's tangent of the first angle plus tangent of the second angle over 1 minus tangent of the first times tangent of the second. So kind of know what you're dealing with. So I'm using the same triangles as I did in the last example. So the alpha triangle is the same as the last one, and so is the beta one. So we can just grab the information that we need. Make this a little bit quicker here. All right, so tangent of alpha. I'm going to go back to my picture. In the alpha triangle, tangent would be 12 over 5, so opposite over adjacent, so 12/5. And then plus, let's go to the beta triangle. So go back to my picture. The beta triangle here, tangent would be 4 over 3, right? Opposite over adjacent, so 4/3. And then the nice thing with the tangent formula, you actually end up using the same numbers in the top as you do in the bottom. So it's going to be just the 12/5 again and the 4/3. All right, so order of operations, let's just kind of power through this here. Numerator, we have to add those together. There's just no way about it. We're going to have to do some adding. And then the denominator, even before we can subtract, we're going to have to multiply. So we'll kind of strictly follow order of operations here. That would be 48 over 15, multiply numerators and denominators. Now we need to get some common denominators. So in the top, looks like we'd want a common denominator of 15. So I'm going to multiply the first fraction by what? Going back to our middle school math here, that would be 36, top and bottom by 3. And then second one, top and bottom by 5. So why can't you just do the bottom? Well, then you're changing the value of the fraction, right? We're multiplying by something that's equivalent to 1 to express that fraction in a like denominator. So that would end up with 56 over 15. Okay, now in the denominator, let's take a peek and see what we have going on with that one. So we had 56 over 15 in the top. Bottom, I have this 1. I'm going to have to express that with a common denominator. So think of that as 15 over 15. And then we need to subtract. So I need to figure out how far apart 48 and 15 are. So it looks like 33. And because I'm doing 15 minus 48, that would be negative 33 over 15. Okay, and now you're ready to multiply by the reciprocal. All right, so 56 over 15 times 15 over negative 33. Looks like I'm going to end up with 56 over negative 33. So that would be the tangent of alpha plus beta. So 56 over negative 33. So let's think about what we know about these two angles then. So angle alpha and beta were both quadrant 1 angles, and my tangent answer ended up to be negative. So when I added those two angles together, there's no way I could have ended up still in quadrant 1, right? Because tangent is negative in quadrant 2. So I know immediately that these angles added together put me into quadrant 2. So if you do that inverse sine and inverse cosine back in those originals again to figure out what those angle measurements are, what you're going to find is when you add those two angles together, you must have been in quadrant 2 because that's what tangent came out to be. So thinking about reasonableness and where things are is really helpful. All right, so that's our day 2. This is looking at knowing ratios. Not knowing anything about angles, we can still do these expressions. So now we've covered basically 3 different things. We've looked at verifying, showing that two graphs are the same. We've talked about expressing non-special values using special value angles. And now we talked about using ratios and triangles to help us do sine or sum and difference. So we have lots of different options and applications out there for 7-3.